Hello guys, this is our periodic table section of Unit 1.2. Here are the learner objectives that we're going to explore in this section of the PowerPoint. Firstly, we're going to see the elements being arranged in order of increasing atomic number and in groups and periods in a modern periodic table, with elements having similar properties appearing in the same groups. Metals being found to the left and center of the periodic table, and non-metals to the right, with elements having intermediate properties appearing between the metals and non-metals in each period. The electronic structures of the first 20 elements, so from hydrogen to calcium. And lastly, we're going to have a look at how the electronic structure of any element is related to its position in the periodic table.
Let's look at the arrangement of the elements in the periodic table. So all elements that have been discovered are arranged in a table called the periodic table, which was first arranged by a Russian scientist, Dmitry Mendeleev. The periodic table is arranged in order of increasing atomic number, which means in order of increasing number of protons in an atom. The columns are called groups, and we start from the left-hand side with groups 1 and 2. And then the section in the middle of the table that we see here in blue, transition metals, skip the numbering system, and we start with group 3 from boron and continue to count up. After group 7, which is the halogens, we have the noble gases, which is usually referred to as group 0. Again, these are the groups. Rows in the periodic table are called periods. So, starting from hydrogen, that's period 1, and we work down, and we're just concentrating on the first 20 elements. So we're going down to period 4. Mendeleev arranged the elements on the periodic table so that the elements are in the same group which have similar properties. We have metals on the left-hand side of the periodic table and the non-metals on the right-hand side of the periodic table. There is a divide line between the metals and non-metals, which has been shown on the table as a sort of staircase.
Properties of metals and non-metals. Both metals and non-metals have different properties. Metals are great heat and electricity conductors and are shiny. They are also hard, strong and malleable. They have a high density and are all solids at room temperature except for mercury. Non-metals are pretty much the opposite of metals. They have low conductivity of heat and electricity as they are insulators. They are dull, weak and brittle. They have a low density and are also present as gases, liquids and solids at room temperature. The elements that lie close to the separating line, such as boron and silicon, share metal and non-metal properties, which means that they can behave as metals or as non-metals.
Next, we're going to look at the electronic structures. So electrons in atoms occupy energy levels, which are also called shells. And each shell can hold a certain number of electrons, and the lowest energy shell, which is the one closest to the nucleus, is filled first. So the first shell can hold up to 2 electrons, and every next shell can hold up to a maximum of 8 electrons. So here we're going to go through 3 examples of electronic structures. However, for your GCSEs, you need to be able to draw electronic structures for the first 20 elements, so from hydrogen all the way down to calcium. We also provided a worksheet for you with all the electronic structures from hydrogen to calcium, so you can practice them. So the first example that we're going to go through is lithium, and lithium has 3 electrons. So we start filling them in from the lowest energy shell, the one closest to the nucleus, and we can only fit 2 electrons in there. So the remaining 1 will go into the second energy shell. Nextly, we have oxygen. Oxygen has 6 electrons. So again, 2 will go into the lowest energy shell, and the remaining 4 electrons will go into the second energy shell. Lastly, we have calcium. Calcium has 20 electrons, and it's also the most difficult structure you'll have to know. So again, we put 2 electrons in the shell closest to the nucleus, and then 8 electrons in every next shell, all the way down to 4th shell, where you only put the 2 remaining electrons, so that you have 20 electrons altogether. The number of shells that an atom has corresponds to the period that the atom is in. For example, if we look at lithium, lithium has 2 shells and it's in period 2. Furthermore, the number of electrons in the outermost shell corresponds to the group that the atom is in. So for example, if we look at the oxygen, oxygen has 4 electrons in the outermost shell and it is in group 4 on the periodic table.
Thank you for watching this video. See the next video for continuation on the periodic table.